Okay, Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to show you 3 examples on chapter 6. So if you look at this example, we have 3 different sides. Okay, 1, 2, 3. So I'm going to cover one by one. Okay, so first I'm going to cover example number 1. Okay, for example number 1, okay, given the system function z as equal to 9z over 3z minus 3z squared plus 0.9z minus 0.54. So what you have to do is you need to determine the poles and zeros, and you need to determine the hn, in which you need to specify the ROC, stability and causality of each hn. So basically, as you know, how to get the zeros value, it is coming from your numerator part. Okay, and then how to get the poles value, it is coming from your denominator part. Okay, so if you look at this transfer function, it is actually not similar to the general transfer function that you need to have. Okay, so what you have to do first is actually you need to modify this transfer function. Okay, instead of it is in z, now you have to make sure that the transfer function is basically in hz equal to z minus 1 over blah 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 z minus 2 form. Okay, so for you to do that, okay, it's involved with mathematical expression. Okay, so you need to really master your maths before you want to answer this one. Okay, in example 1, okay, we have hz equal to 9. So we want to make it become similar to our general transfer function. So what we have to do is you need to divide this one with z squared. Okay, why we divide this transfer function with that z squared? Because of, if you look at the denominator part, in denominator part the highest order is z squared. So basically you have to refer to your denominator part, and then you have to take the highest order of your denominator part. So basically the highest order is z squared. Okay, why we divide z squared with its own function z squared also? Because of, okay, we don't want to have a new transfer function, new added transfer function. So that's why the same function z squared, it must divide with the same function, so that if we kill off this z squared, you didn't disturb your original function, right? Okay, so we're gonna have z. So we have this one. Okay, but again, if you look at this transfer function, it is not similar to our general transfer function. So what you have to do next is you have to modify again this transfer function. So for you to modify again, you have to make sure this part must equal to 1. Okay, so you need to factor out. So what happened? This part will become z minus 1 over, you factor out, so you have 0 0.3 z minus 1 minus 0 0.18 z minus 2. So you kill this one, so you have 3z minus 1 over 1 plus 0 0.3 z minus 1 minus 0 0.18 z minus 2. So based on here, you know that for your zeros, you have z equal to 0. For your poles value, you cannot determine straight this one. Okay, so what you have to do is you need to factor out. So you factor out the denominator part. So when you factor out, you can just use your calculator. Okay, you will have 0.6 z minus 1, and then 1 minus 0.3 z minus 1. Okay, so your poles equal to minus 0.6 and 0.3. Okay, so done for part 1. Okay, next we refer to part 2. Okay, so you have to determine the HN. Okay, and then you have to find ROC, stability and causality. So we are going to determine your ROC. Okay, so basically to answer part 2, first you need to determine your ROC. So how to get your ROC? ROC you get from the poles value. Okay, so you refer to your poles value. Okay, your poles value is minus 0.6 and 0.3. So what happened? Okay, you draw this one, real, imaginary. So you have 0.3, and then you have minus 0.6. So this is two poles. So basically you're gonna have 3 ROC. So you're gonna have right-sided, left-sided and two-sided. Okay, so if you look this one, if you still remember, okay, go back to your lecture. Okay, for ROC it must be at the positive part. Okay, so means the value, it is actually negative 0.6 is actually 0.6 at different direction, minus at different direction. So basically for you to make your ROC, make sure this is the general terms. Okay, your modulus Z, it is either less or greater or equal to modulus A. So you have to make sure that your A must always positive value. So that's why if you look here, okay, we have negative. So the different direction of negative 0.6 is 0.6. Okay. Okay, so for your right-sided, okay, go back to the theory. Right-sided is greater, is outside outermost pole. So 0.6 is your outermost pole. So modulus Z is greater than 0.6. Okay, for left-sided, it is inside innermost pole. So basically your modulus Z is less than 0.3. For two-sided, it is in between two poles. So basically your modulus Z is in between 0.3 and 0.6. Okay, done for ROC. Okay, next, from ROC we can determine your HN. So basically for you to determine your HN, okay, so basically you have your HZ. So what you have to do first is actually you need to use partial fraction. So use partial fraction. So your HZ will be HZ A over 1 plus 0.6 Z minus 1 plus B over 1 minus 0.3 z minus 1. So basically, for you to get A, it is you need to replace all z with minus 0.6. Okay, so after you replace all z with minus 0.6, you will get your A. So A is minus 3.33. Okay, you replace his z. Okay, next B is equal to his z. You replace z with 0.3. So you will get positive 3.33. So basically your new his z after partial fraction, it is negative 3.33 over 1 plus 0.6 z minus 1 plus 3.33 over 1 minus 0.3 z minus 1. Okay, so for you to determine your Hn, how to get Hn, you need to refer to your ROC. Okay, just now here we have 3 ROC, right-sided, left-sided and two-sided. So for you to determine Hn, you need to determine Hn for each ROC. So first, let's say we do for right-sided. Right-sided modulus z is greater than 0.6. Okay, so what you have to do next is, okay, we have 0.3 and then we have negative 0.6. Okay, right-sided means all your poles will approach to right. So also approach to right. So the function is un. So for you to get Hn is you need to find the inverse Z transform. Okay, so that of his Z, so that you get Hn. Alright, so minus 0.6 is approach to right. So the function is un. 0.3 also is approaching to right. So the function is un. Okay, then for right-sided. Okay, next for left-sided. Okay, left-sided modulus z is less than 0.3. Okay, so we have 0.3 and then we have minus 0.6. Okay, left-sided means all the poles will approach to left. The function is minus u minus n minus 1. Okay, so again, same thing. You need to find Hn. So Hn is the inverse Z transform of Hz. So 0.6 is approach to left. So the function is minus u minus n minus 1. So negative negative become positive. U minus n minus 1. Okay, then for left-sided, next two-sided. Two-sided is in between 0.3 and 0.6. Okay, so we have this one. Okay, so we have alright, so what happened? Innermost pole will approach to right. Outermost pole will approach to left. Okay, so we have to the right is un, to the left is minus u minus n minus 1. So for you to determine hn is the inverse z transform of hz. So you have hn, so hn is equal to, okay, so we have this one, the original transfer function from the transfer function. So we have okay, 0.6 is approach to right, so is approach to left, so it is minus u minus n minus 1. So this one become plus u minus n minus 1. 0.3 is approach to right, so the function is un. Okay. Okay, now you need to, from the question, you need to specify the stability and causality of each impulse response. So it is causal because it is right-sided region, and it is stable because the region includes unit circle. Okay, for left-sided and two-sided, same thing, it is not causal because it is left-sided region, it is not stable because the region does not include unit circle. For two-sided also, it is not causal because it is two-sided region. So you have to put it, because it is two-sided region, it is not stable, again because the region does not include unit circle.